Hi, good afternoon, everyone. How are you all? Hope you are doing well. We will be starting discussion on this MSQs, right? MSQs on what? Railway engineering, right? So till now we have seen these MSQs on highway engineering, but we did not see for railway engineering. Now we'll see in railway engineering. Okay. Right. Myself, Rajendra Prasad. These are all the subjects I'll be taking in Unacademy app. So 8 years of experience in which one? 8+ years of experience in coaching field and 9 years of experience in teaching field totally. So previously worked in ESE Academy and GATE Forum, and this is my referral code RPCB you have to use when you are subscribing for Unacademy Plus courses. All of you are having Unacademy learning app? All of you are having Unacademy learning app or not? Do you have? Okay. If you do not have this Unacademy learning app, try to download this Unacademy learning app. Then search with RPCB. Then you can find my profile Rajendra Prasad K. Then you can follow me, so that you will be getting updates on my classes, free classes and plus classes also. Now, these are all the subjects I will be taking in Unacademy Plus platform. You can say. This is our faculty team, myself, RP sir, next KP sir, next AR sir. We three together will be teaching in English language in Unacademy Plus platform, right? English language in Unacademy Plus platform, you can say. Now, RP Civil is the code you have to use when you are subscribing for the Plus courses, you can say. Okay? Now, KP sir, these are all the subjects taken by KP sir. RP sir, myself will be taking these subjects. Rafi sir will be taking only geotechnical, except geotechnical, remaining all civil core subjects are taken by KP sir and myself only. Price hike already it was over yesterday. From yesterday onwards, the price hike was increased. Price hike was effective. So up to yesterday evening 6 o'clock also they have given time. They have extended actually. You can say. Now these are all the courses I have started, right? Transportation engineering complete course, structure analysis complete course, airport engineering, plastic analysis, steel structural design. These are all the courses done. Plastic practice course on structure analysis also done. Complete course on surveying was also done. Crash course on transportation engineering for GATE also. It will be starting, right? On 21st November it will go up to 10th December. And complete course on reinforced concrete structure, it has just started on 17th October. It will go up to 17th November, right? So those who are willing to subscribe, right? Those who are willing to subscribe for the plus courses, so that you will be avoiding missing of these classes of these subjects. Then what you do is you subscribe as early as possible, but don't forget to use this code RPCivil while subscription. Okay? Or you can contact me at my number also if you are having any doubts regarding. Coming to this complete course on this reinforced concrete structures, the details of the course. It was started on 17th October. It will go up to 17th November. The timings are which one? 5:30 to 7:30 every day. These are all the contents I will be discussing there. These are all the contents corresponding to GATE and ESE, both I will be discussing, right? Except that masonry structures and earthquake resistant design. Except this masonry structures and earthquake resistant design of structures, everything is done, right? Everything is done. Everything will be done here. Now, what are the benefits you will be getting when you are subscribing using my code RPCivil? These are all the benefits you will be getting when you are subscribing by using my code RPCivil. Okay. So you can follow my profile at this link, https://unacademy.com/@RPCivil. Okay. So these are the classes. 21st today MSQs on railway engineering, and 23rd day after tomorrow will be the last class on YouTube for this month. Again we'll meet in the next month. So again on 25th we'll be having that interactive session with the Bark scientist and CE. Okay. Actually, we have planned last Sunday, but due to some technical issue, it was not done. Now we'll be commencing that. MSQs on which one? MSQs on this railway engineering, right? Now, if you just observe MSQs on railway engineering, the questions, first question. Grade compensation. Okay. Grade compensation for grade compensation as per Indian Railway specifications is, what is it here? Option A, 70 by R for broad gauge, 75 by R for broad gauge, 35 by R for narrow gauge, and D will be what? 70 by R for narrow gauge. So like that. So which one can be correct if you just observe? As per Indian Railways, right? As per Indian Railways specifications, right? As per Indian Railways specifications, what is that grade compensation? You can say grade compensation equal to 0.04 percentage per degree of curve in case of broad gauge. So 0.04 percentage for 1 degree means what? For d degree, how much it will be? 0.04 times degree for broad gauge. 0.03 percentage for 1 degree means 0.03 times degree for which one? For meter gauge. And for narrow gauge, how much it could be? 0.02 percentage per degree. So 0.02 times degree, 0.02 value for 1 degree and 2 d for d degree. This is for narrow gauge, you can say. And if you convert that in terms of radius values, how can you convert that to degree to radius? We know that degree equal to 1750 by radius. Only this one we have to use, right? 1750 by radius you have to use, right? Don't use 1720. 1750 by radius you have to use as per which one? The new specifications of Indian Railways, right? As per the new specifications of your Indian Railways students. Okay? Now, how can you get this? 0.04 into 1750 by radius. If you simplify this, 70 by R for broad gauge. So first option is correct, or 70 by R for broad gauge. So 75 by R for broad gauge is wrong. Next, 0.03 into 1750 by radius. So what is that? 0.03 into 1750, how much it comes to be? 52.5 by R. Next, 0.02 times 1750 by radius, it will be taken as what? Half of the broad gauge value exactly, so means 35 by R for narrow gauge. So which one is correct? 35 by R for narrow gauge is correct, 70 by R for narrow gauge is wrong. So which option is the correct one? Exactly, you can say option A and option C. Both are correct. Good afternoon, Rajesh. How are you? Right. So here like that. That is your first question. If you observe, which of the following curves are not preferred as transition curve for railways. For railways, you can say, right? For railways, right? For railways, which of the following curves are not preferred, right? Not preferred, right? Yeah, I'm also fine. Just how are you? Had your breakfast? A, let us say, clothoid. B, cubic parabola. C, cubic spiral. Next one is what? Bernoulli's Laminsky. So if we just observe, which one is the transition curve preferred for Indian Railways? Which one is the transition curve preferred by Indian Railways, you can say? For railway transition curve, which one is preferred? I'm waiting for your answer. Which one is the transition curve shape preferred by Indian Railways, you can say now? Okay, right. So if we just observe, clothoid is the curve preferred mainly for which one? This is the curve mainly preferred for which one? Highway transition curve. It is not preferred for railway. Okay, not preferred for railway. Okay, cubic parabola is the only curve preferred for railway transition curve, right? So cubic parabola is the curve preferred. Cubic spiral is also not preferred for railway, you can say. Bernoulli's Laminsky is also not preferred. So which one are the curves not preferred for railway? A, C and D, right? These are the three curves not preferred for railway, right? Which one is preferred for railway? Only cubic parabola is preferred for railway. Why not clothoid spiral? Why not clothoid or spiral? Glover's spiral, you can say. If you just observe, because for a highway we are representing the clothoid. Whenever it is a clothoid or Glover spiral, it is like this. This is your Bernoulli's Laminsky and this is your cubic parabola. If you just observe, right? If you just observe, what will happen? Whenever spiral is there, throughout the length, uniform rate of change of radius is only there, right? Throughout the length, uniform rate of change of radius is only there. But what will happen? Throughout the length, uniform rate of change of radius is only there. But what is the problem here? But it is a very fast decrease in the radius. And if you just observe, your first bogie is at this. If it is a highway vehicle, very small length of the vehicle from first point of the vehicle to last point of the vehicle, very small change in the radius. But if it is a railway vehicle, if you try to observe, the length of the train or length of the railway vehicle is very, very higher. Yes or no? In place of one bogie of train, we can place 2 to 3 lorries or not? We can place 3, 4 lorries or not? Yes. One bogie length is equal to 3, 4 lorries length. Then in place of one train, how many lorries you can place? Many number of lorries you can place it or not? Yes. So the first part of the train is having very smaller radius. Last part of the curve is having vehicle is having which one? Very large radius, right? Here 200 meters, here 25,000 meters. Then it is very critical or not? Yes. But if you consider this cubic parabola, what will happen? The rate of change of radius is very slow compared to that spiral. Then from this first point locomotive to the last bogie, the change in the radius is very, very small. So which one is preferred? Obviously, which one is preferred? Obviously, it is better you prefer this cubic parabola only because of smaller change in the radius, right? Which are not used for railways. Clothoid, cubic spiral and Bernoulli Slamin skirt are not used for spiral. Okay, only cubic parabola is used for spiral. Not preferred means what? Which are in 2 marks, which are within 2 marks, you have to select that as the answer. Okay, like that. Now, next question. Here, what you can say? Identify which one? Correct statements. Identify correct statements. So which one are the correct statements or wrong statements you are supposed to identify, right? First one is what? Maximum cant allowed is 185 mm always. Second one, what is it? Second one you can say. Maximum cant allowed is also 140 mm sometimes. Next, maximum cant allowed is also which one? 90 mm sometimes. Maximum cant allowed is 100 mm always, as per Indian Railway specifications, right? As per which one? As per Indian Railway specifications, you can say, right? As per these Indian Railway specifications, what are the maximum cant values? You can say, anyone? Cant or super elevation values. There are certain limits given by which one? Indian Railways, right? There are certain limits given by Indian Railways, right? What are these limits given by Indian Railways? You can say broad gauge, if you consider. Whenever it is a broad gauge, right? Whenever it is a broad gauge for group A, B and C, and for DE it is given differently, right? Again, there are two specifications here. Under normal condition, and this is with under special condition, right? Under special condition. So with special permission of chief engineer, we have to select, right? ABC, it is given as how much? 165 mm. It is taken as what? 180 mm. 185 mm, right? 165 mm, and it will be taken as which one? 180 mm, you can say, right? 180 mm. So here this is for C also, right? This is A. Next, B comma C. This is also 165 mm only, dash. This is 140 mm, D comma E, 140 mm dash, you can say. These are the values allowed. Okay, now, and if it is a meter gauge, you can say, if it is meter gauge, what you can say? If it is meter gauge, 90, with special permission of chief engineer, 100. And if it is narrow gauge, how much it comes to be? If it is narrow gauge, how much it comes to be, you can say? If it is narrow gauge, it is 70 and it will go up to which one? Or 65, 95, right? So these are the other values you can say, right? Now, here if we just observe for broad gauge, right? What is that? Under normal condition for broad gauge, group A, right? Whenever it is a group A, right? Whenever it is a group A type, what is that? 165 mm is the maximum value under normal condition. With special permission, 185 mm, right? With 185 mm. So always maximum count allowed is 185 mm always. Is it always 185 mm? No. Only under special conditions, that too for broad gauge group A, we are allowing it as 185 mm, right? When you can say it is a group A, when you can say it is a group A, when you can say it is a group A. So here narrow gauge terms are not given in the question, so don't worry about these narrow gauge values. Only look at these broad gauge and meter gauge values. We just observe when you can say it is a group A. If you wanted to call this particular railway tracks as group A, will come under group A. Those are allowed with which one? 160 kmph speed. The railway track lines which are allowed with 160 kmph speed are your group A. Group B, 130 kmph speed, right? Group B are corresponding to which one? 130 kmph speed. And group E or group C are which one? Group C are corresponding to urban rails, right? Urban lines, right? Which urban lines? Urban lines, suburban lines, or urban lines of suburban lines of Mumbai, Delhi, and Kolkata. Only these three cities, right? Not other cities, right? Because if we just observe for Mumbai, even though you call it as a local train, but that local train of Mumbai will be moving up to the Pune also. Then what you can say? Then what you can say here? Then you can say that those local trains are running over the other districts also. Therefore, they must be taken care by which one? They must be taken care by which one? Indian Railways, right? Not the urban authority of Mumbai. Okay, like that. So group C is corresponding to suburban lines of Mumbai, Delhi, and Kolkata only. Not Hyderabad, Bangalore, Chennai are not included in this. D. Group D means what? These are also main lines with which one? 100 kmph speed allowed. But group E, all these secondary lines or branch lines will come under group E. You can say it like that. So there is no such classification in meter gauge. Now here, 185 mm always is wrong, na? Because this is allowed. Because this is allowed when? Because this is allowed when? 185 is allowed only for broad gauge under special condition. Broad gauge under special permission with chief engineer only it is allowed. Also 140 mm sometimes. Yes, 140 mm when you are allowing under normal condition for broad gauge with group D and group E tracks. Yes, it is correct. Sometimes 90 mm. Yes, 90 mm is for which one? Meter gauge track under normal conditions it is 90 mm, right? Yes, that is also correct. 100 mm always is also wrong. Okay, so which options can be correct now? Options B and C can be correct here, right? Options B and C can be correct here, right? Like that we can select the answer. Like that we can select the answer. Now question number 4. Which of the following statements are true with respect to transition curve? Which of the following statements are true with respect to which one? Transition curve you can say, right? With respect to transition curve you can say. First one. What is a transition curve you can say now here? Maximum allowed cant gradient is 1 in 720. Maximum allowed cant gradient is 1 in 720. Normally maximum allowed cant gradient is 1 in 360 under any condition maximum rate of change of cant or cant deficiency is 55 millimeter per second. 55 millimeter per which one? Second, right? 55 millimeter per second. Now, the desirable minimum cant gradient is 35 mm per second, right? 35 mm per second, right? Minimum cant gradient, minimum which one? Rate of change of, right? What we have written here? Rate of change of, na? Minimum, the desirable minimum rate of change of cant or deficiency is 35 mm per second, right? Option A, none. So which one can be correct if you just observe all these things? When you say length of the transition curve equal to 0.72 EA, where EA we have to substitute in millimeter, L we have to L will be getting in which one? Meters, you can say. And this is based on what? Maximum cant gradient of 1 in 720 only. Maximum cant gradient of which one? 1 in 720 only. 1 in 720 only, right? 1 in 720 only, you can say, right? Like that. Now if you just observe cant gradient, what is the meaning of this cant gradient? This is your straight line portion, this is your horizontal curved portion, and we are providing a transition curve here. And at this place, what is the cant? At the first place, 0 is the cant. At this last place, what is the cant? Actual cant, EA. And what is the total distance? L is the length of transition curve. Simple meaning of gradient is what? Reduce the level of the last point minus reduce the level of the first point divided by distance between them. Now, reduce the level of last point minus reduce the level of first point by distance between them. Now, temperature gradient is what? Temperature of the last point minus temperature of the first point by distance between them. And similarly, cant gradient is what? Cant of the last point minus cant of the first point by distance between them. What is the cant of the last point? EA. Cant of the first point is 0 divided by distance between them is L equal to 1 in 720. So how can you get this now? If you just rewrite this, L equal to 720 EA. When you are substituting EA in millimeter, you will be getting L also in millimeter. How can you get that L in meters? By multiplying this entire expression with 10 power minus 3, you will get that value of L in meters or not? Yes. So multiplying with the 10 power minus 3, it will become 0.72 EA. That is what. Like that we are telling, right? Now at this place, cant is 0, cant deficiency is also 0, you can say. At this place, cant deficiency is equal to which one? ED2 equal to ED fully. Now, cant deficiency also we have to introduce gradually or not? Yes, both must be introduced gradually with the same rate. What is that rate we are using? Based on the rate of introduction of cant or cant deficiency, how much it will be? 0.008 EAV maximum, 0.008 EDV maximum. L you will be getting in meters. EA and ED we have to substitute in millimeters. Vmax you have to substitute in kmph. So this formula is based on what? This formula is based on rate of change of cant and cant deficiency. Based on which one? Based on rate of change of cant and cant deficiency of how much? 35 to 55 mm per second. So for 1 second traveling of your vehicle, right? For 1 second traveling of your vehicle, for 1 second traveling of your vehicle with that V maximum speed, how much cant must be introduced? 55 or 35 to 55 mm cant must be introduced per second. So therefore, minimum value is 35 mm, maximum value already is 55 mm. We just observe, first one is correct. First one is correct, yes. Allowable cant gradient is 1 in 720. But sometimes if the space is restricted, we cannot allow 1 in 720. So to introduce 1 centimeters of cant, we need to go for 720 centimeter horizontal distance. Yes, na? To introduce 1 centimeter of cant, to introduce 1 millimeter of, to introduce which one? 1 millimeter of cant, 720 millimeters we have to move here. But that is what? Very larger, right? Larger length we have to go for, even for smaller cant also. Suppose if you are taking 1 in 360 means, even for 360 meter horizontal itself, you are getting the required cant. So means within the half length, it will be written as which one? L equal to 0.36 EA when the cant gradient is 1 in 360. Since this 1 in 360 is the cant gradient, you can say. Why you are providing this cant gradient? Even for lesser horizontal distance itself, we are introducing one vertical. Here, 1 in 720 means for a higher horizontal distance, one vertical super elevation we are introducing. But here, compared to this, even for lesser horizontal distance, we are introducing the same vertical. Why it is like that? Because length of transition curve is restricted. Higher length is not possible. So lesser length of transition curve is only possible. Then we are restricting it only for broad gauge. This is not applicable for meter gauge. So maximum allowed cant gradient is 1 in 360 under any condition. Yes, na? Like that. The maximum rate of change of cant or cant deficiency is 55 mm per second. Yes, it is also correct. Desirable minimum rate of change of cant or deficiency is 35 mm per second. Yes, that is also correct. None is wrong. So which one is the correct option? You can say A, B, C and D. You may get it out. Sir, can there be 4 options correct? Yes. 4 options also may be correct, right? 4 options also may be correct, right? It is mentioned in the GATE notification that more than one option is correct. Means simply it is mentioned as more than one option, right? It is 2 or 3 or 4. It is not exactly mentioned. So you can consider which one? 4 options also as correct. Now, so this is what we can take it here, right? Like that. Now, for horizontal curve, if you just observe it, for horizontal curve, if you just observe, for a horizontal curve, for a horizontal curved railway track, for a horizontal curved railway track, which one are correct? You can say reduction of curve resistance, reduction of curve resistance by means of which one? Compensation will be done. Second one you can say. Varsine or setback equal to L square by 8R. Now, what is another one you can say? Maximum allowable degree of broad gauge curved track is 10 degree. Okay, next what you say? Next what is it you can write? Maximum allowable speed, that is V maximum equal to 0.36 under root actual cant plus cant deficiency, actual cant plus cant deficiency into radius for broad gauge. Okay. So now which one can be correct here? Which one can be correct now? Which one can be correct, right? The reduction of curve resistance by means of curve compensation will be done. Is it possible to reduce the curve compensation, reduce the curve resistance? No. Whenever there is a horizontal curve, because of the moment of the train on the horizontal curve resistance will be there. When this is associated with a gradient also, because of the moment of the vehicle on gradient, grade resistance is also there. When curve resistance as well as grade resistance both are present, there is no reduction. There will be more loss of engine power or tractive force will be there. So it will result in what? It will result in more utilization of the engine power, more fuel consumption, uneconomical. Then what we need to do? We have to reduce this loss. How can you reduce this loss? There are two ways. One way is decreasing the gradient by decreasing the gradient. Other one is what? Decreasing the curve resistance by increasing the increasing the radius, you can say, right? But what you can say, increasing the radius is not possible, right? If there is a hill track, right? There is a hill track, you are having a gradient as well as horizontal curve. Now if you try to increase the radius, what will happen? We have to construct the track out of the hill. It is impossible now. So we cannot increase the railway track radius. But what we can do? We can decrease the gradient. How can you decrease? Just by filling like this and just by cutting like this. I have discussed this in detail in my special classes on railways also. You can observe. Okay. Then what is the compensation? How you are doing the compensation? By means of decreasing the gradient. That is why it is called as grade compensation. We are not decreasing the curve compensation, curve resistance. Okay. So this first option is wrong. Second option. Varsine or setback for horizontal curve is how much? L square by 8R. That is correct. How it is correct? See, straight curve, straight. And if your train is at this place, what is the critical condition? From the starting point of the curve, we must be in a position to see the ending point of the curve. Let us say this is a setback distance we require. Over this area, visibility is required compulsorily. From here to here, what it is? L length of the curved track. So when you are completing this, this is 2R minus H. This is L by 2 approximately. This is L by 2 approximately. Then from the property of course, L by 2 into L by 2, left into right equal to upper into lower, right? H into 2R minus H. Compared to this 2R diameter, H setback distance is very very smaller now. So H into 2R. Therefore, what is that setback R version? L square by 4 into 2. So L square by 8R. So that is also correct now. L square by 8R, right? Like that. Now the maximum allowable degree for broad gauge curved track is 10 degree. What is that maximum allowable degree? Degree maximum allowed for broad gauge. So for how much it will be? Broad gauge, meter gauge and a narrow gauge. These are the values. Broad gauge 10 degree, meter gauge is 16 degree, narrow gauge 40 degree. And when the maximum degree allowed is this much, minimum radius allowed is what? 1750 by 10, 175 meters. 1750 by 16, 1750 by 16. So how much it comes to be? 109.375. Right, 110 approximately you can take. Now when it comes to be this one, 1750 by 40, so means 1/4 of that one, 43.75 means you round it off to which one? 44 meters. Like that you can say, right? 44 meters you round it off like this. So these are the minimum radius values, right? What is that given? So for broad gauge it is 10 degree correctly only given, and yes, option C is correct. Maximum allowable speed. What is the maximum allowable speed you can say now? Generally that E theoretical cant equal to actual cant plus cant deficiency. What is the theoretical cant? G into V maximum square by 127 R. And if you substitute that, what is that V maximum? You can get it here under root 127 by G is an under root 127 by G into actual cant plus cant deficiency into R. Now V max I wanted to get it in kmph na, or you have to substitute in meters. If you are substituting gauge in meters, EA and ED also must be substituted in meters. If this gauge is in millimeter, E and ED also can be substituted in millimeter, right? If you are substituting in millimeter, what is it for broad gauge? You can say under root 127 by, what is that broad gauge? Dynamic gauge we have to substitute here na, not the original gauge. We have to substitute the dynamic gauge. What is the dynamic gauge? You can say 1750 means it is center to center distance of the rails, actual cant plus cant deficiency into R. So how much it comes to be? 0.27 into under root EA plus ED into what? R. Like that. But what is that value given? 0.36 is given, means it will be wrong obviously or not? Yes. Which options are correct now? Which options are correct now? Options B and C can be correct here. Options B and C can be correct here, right? Like that you can say. No. Now what is the sequence of transfer of loads? First one is what? Wheel to sleeper, rail. Next, wheel, rail, sleeper. Next one, rolling loads to which one? Point loads, then point loads to line loads. Next, rail, or we'll write this, still at sleeper to rail and then to ballast. So here how the loads will be transferred, if you just try to observe how the loads will be transferred. This is your railway track, let us say. These are your rails. So your wheels are running on these rails, you can say. This is your railway dabba. And below the rails, what you are having? Sleepers are there. Below the sleepers, what you are having? Ballast will be there. Below the ballast, what you are having? Soil. So if you observe, this is your ballast. This is your what? Subgrade or formation. This is your sleeper. That is your rail and this is your wheel, you can say, right? Like that. That is your wheel, you can say. So if you just observe, wheels are rotating or rolling like this now. The rolling loads will be converted. The wheel load will be acting like which one? Rolling load or moving load onto the rail now. So rolling load or moving load onto the rail. That rolling load or moving onto the rail, it will be transferring onto the sleepers by means of which one? Point load or concentrated load over this area or not? Yes. What this sleeper is doing? It is converting these 2 point loads to line load or UDL onto this ballast. Ballast is transferring which one? UDL to which one? Uniformly distributed load or line load in one direction to which one? Area or pressure load onto the soil finally. Like that. So what is the sequence? You can say rolling, rolling loads to point loads, then point loads to UDL or line loads, and then area loads. By which one? Rolling loads are transferred by which one? Rail to sleeper point loads, but sleeper to ballast UDL, ballast to soil, it is area load, right? So what is the sequence of loads now? If you can observe, wheel, sleeper, rail, right? Yes, na? Wheel to rail, right? From wheel only the load is transferred onto the rail. Wheel. So from the wheels, loads are transferred onto the sleeper directly, or first they will be transferred onto the rail. Wheel to sleeper is wrong. Wheel to rail is correct, right? First option is wrong. Wheel to rail, rail to sleeper is correct. Yes. Rolling loads to point loads to line loads, is it not? Rolling loads are converted to point loads are converted to line load, line loads are converted to area load. Rolling loads, point loads, line loads. Yes, na? That is correct. Sleeper, rail, ballast, right? Sleeper to rail to ballast, it will be transferred, right? Which option is correct now? B, C and D, right? Yes, na? Sleepers, ballast, soil. Okay? Sleeper, rail, ballast, right? Sleeper, rail, ballast is also wrong or true or wrong? Wrong actually. Sleeper to rail, it will go again. Sleeper to rail, it will not go, right? Sleeper to rail, it will not go, no? Sleeper to ballast to soil, right? Rail will not come in between. So which options are correct? B and C are correct, you can say, right? B and C options are correct, you can say, like this. Just a minute. The slides are over. I'll be adding more slides here. I'm adding these slides. Just a minute. Okay. So this is the sequence, right? This is the sequence, right? Like that. No. Which question you have to select now? Here, if you just observe. Which of the following limit or limits are allowed for what? Gradient in railways. So which of the following gradients are allowed in which one? Railways, you can say 1 in 150. Sorry, 1 in 150. 1 in 100. 1 in 75. 1 in 30. What are the maximum limits allowed? If you just observe ruling gradient. What are the gradients taken? 1 in 200 to 1 in 150, right? So 1 in 150 is the maximum value. Gradients in railways under corresponding conditions. Corresponding condition means whatever the conditions are there under those respective conditions, these are allowed. So here for ruling gradient 1 in 150 to 1 in 200 in case of what? Plain terrain you can say. And it will be taken as what? 1 in 150 to 1 in 100 for which one? Hilly terrain. Next. That is your ruling gradient. Next, what is the pusher gradient? You can say 1 in 75 in general. It should not be greater than which one? 1 in 25, right? Should not be greater than which one? 1 in 25, right? Should not be greater than which one? 1 in 25, right? What are the values correct now? 1 in 150 is the maximum limit for ruling gradient in plain terrain. Yes. 1 in 100 is the maximum limit of ruling gradient for hilly terrain. Yes, correct. 1 in 100 is also correct. 1 in 75. 1 in 75. Yes. Pusher gradient is what? Should not be greater than which one? 1 in 75. Should not be greater than which one? 1 in 75 in general. So that's also correct, right? But next value is what? 1 in 25 is correct, right? It is not 1 in 30. So which options can be correct now here? Option A, B and C can be correct. Like that. Next. Which one are correct now? You can say here. Russian formula of weighted average speed of equilibrium cannot be one or many of the following. Which one? Here it is can't, here it is can't, right? Can't, cannot be, right? Equilibrium, super elevation otherwise. Which one? V equilibrium equal to N1 V1 plus N2 V2 plus so on divided by what? N1 plus N2 plus so on. B. V equilibrium equal to 3/4 of this V maximum. See what is the V equilibrium? Under root. Which one? N1 W1 V1 square plus N2 W2 V2 square divided by what? N1 W1 plus N2 W2 plus so on. Okay. Then no answer. Otherwise you can write this one also. What is this you can write? 4 point, right? V equilibrium equal to 4.35 into root r minus 67. So what are these values? Just observe. This is your weighted average formula. N1 V1 plus N2 V2 plus so on divided by N plus N2. That is your normal weighted average formula. Normal weighted average formula. It is not which one? Russian formula. This is V equilibrium equal to 3/4 of V max. This is also not the Russian formula. But this is the Russian formula, right? This is only which one? Russian formula. And this one is also not the Russian formula. This is not the Russian formula. This is which one? Martin's formula. So therefore, which one is not? Sorry, which one is not? This is also not the Russian formula. Which one are not the Russian formulas? A, B, and D, right? A, B, and D are the Russian formula, right? Other Russian formula. A, B, and D are not the Russian formula. Only this C is the Russian formula, right? N1 is the number of trains with weight W1 traveling with speed. N2 is the number of trains with weight W2 traveling with speed. That is what given by Russian formula. Indian Railways is using the same one, right? No. What you can say? Which statement or statements are true? What is it you can say? Cant deficiency and cant excess will be taken care by coning of wheels. Govind, sound echo. Just refresh, Govind. Govind, just refresh. Now you will be getting correct one. Just refresh, Govind. Just refresh and observe, Govind. Now is it okay or not? Just refresh and check, Govind. Did you check? First one is candidate efficiency and candidate access will be taken care by coning of wheels, coning of slope of wheels and tilting slope of rails is same. Maximum candidate efficiency is 75 mm for broad gauge under normal condition. For broad gauge under which one normal condition you can say. Next. Maximum speed based on length of transition curve. Is equal to 134 L by E, right? Under normal conditions. Okay. Here. Maximum speed based on length of transition curve equal to 198 L by EA under normal conditions. Like that. Sunny. No. Okay. Is it okay? Right. So which option can be correct among all these? Which option can be correct? Yeah. Because coning of wheels will be taking care of same amount of access and same amount of deficiency of candidate definitely na? Yes or no? In that special class which we discussed, if you remember, we have discussed this point and we have given these values also, if you remember. Yes, no? What is Sunny? No? Candidate efficiency and candidate access both will be taken care by coning of wheels only, right? Both are taken care by coning of wheels only, right? Both are taken care by coning of wheels only, right? Both are taken care by coning of wheels only, right? What is no Sunny? Don't you know these values? This railway special class, right? Railway special classes have taken in Unacademy. Unacademy only the special classes only, no? In railway special classes are there, no? These 15 special classes are railway have taken, no? Dwarak. 15 special classes have taken on these railways, no? There have given this under geometric design railway special classes, right? PVQs and MCQs on railways geometric design part, right? Those 3-4 parts I have taken 3-4 classes. In that class you can find this deficiency and excess. Okay? Recently we have taken just this month and last month together only we have taken September, October together only we have taken those classes, na? Yes, na? In those classes only. How much it will be taken care by coning of wheels, right? Coning of slope, coning slope of wheels and tilting slope of rails is same. Both are same or different? If your wheels are like this, right? If your wheels are like this, what will happen? Wheels are having some coning. What is the slope of this coning? You can say 1 in 20. And when you are placing your wheel here, what is the problem you will be getting? Let us say this is a rail. And if you are placing the wheel like this, on the opposite side, opposite wheel will be there. What will happen? Only contact will be present at this portion, so damage or rubbing action will occur at this place only. Uniform distribution of load onto the rail is not possible. Then what we have to do here? We have to tilt the rails also, right? We have to tilt the rails. When you are tilting the rails by some slope, what will happen? You can place the wheels like this now. Full contact between the rail and wheel is possible or not? Full contact between the rail and wheel is possible. When full contact is possible, when these rails are also tilted with the same slope 1 in 20 only or not? When the rails are also tilted with same slope 1 in 20, right? Coning slope of wheels and tilting slope of rails is same. Yes, no? Otherwise, if these two are different. This is a coning slope of wheels, let us say, but a tilting slope of rails is something else again. Then what will happen? Full contact is not possible. So we have to provide which one? Same slope only, na? The rails also must be tilted inwards with the same slope, right? Same. What is that value? 1 in 20. Maximum candidate efficiency is 75 mm for broad gauge under normal condition. So I repeat, broad gauge normal condition 75 mm, meter gauge normal condition 50 mm, narrow gauge normal condition, normal speed up to 100 kmph 40 mm, right? And if it is for high speed track for broad gauge, what is the candidate efficiency? 100 mm, right? Like that. So this is correct or not? For a broad gauge, normal speed track 75 mm, high speed track 100 mm. Okay? Yeah. Meter gauge normal speed track 50 mm. High speed track, no values different, means not allowed. Narrow gauge, normal speed track 40 mm, high speed track not allowed. Like that. This one. Maximum speed based on the length of transition curve equal to 134 L by E under normal condition. Under normal condition it is correct, but it is 198 L by E is under which one? High speed condition. Under high speed condition. So which one is correct? D is correct. So which options are correct now? A, B, C and D are correct. So is that clear, Govind? A, B, C are correct. This 198 L by EA is the maximum speed expression under high speed condition, right? Where L is the length of transition curve. EA is the actual. So is that clear? Shall I move to the last question now? Yes, no? C is also correct. A, B, C and D. Other correct. Except E. No. Here if we just observe, what you can see? Which statements are true when a main curved track or when from a main curved track a branch curved track is diverging in opposite direction. Is diverging in opposite direction, right? Is diverging in what? Opposite direction, right? Like that. So this is your main track, just for an example. And there is one branch track diverging in opposite direction. So this is the outer rail for main track, this is inner rail for main track, this is outer rail for branch track, and this is inner rail for branch track. These are the 2 points A and B. Now, do you remember this discussion also done in Unacademy special classes? Just remember, our main track is having positive superelevation, branch track is having which negative superelevation. Those statements, do you remember? Main track has negative superelevation. Branch track has negative superelevation. Superelevation value on both tracks is same. Next. Maximum speeds on both the tracks are interrelated. No. Tell me which one is correct, all of you? Which options are correct for this last question? I'll be waiting for your answer. I think there is some lag. Tell me, main track is having negative superelevation or branch track is only having negative superelevation? Branch track is only having negative superelevation. Main track is having positive superelevation. Main track is having positive superelevation. Branch track is having negative superelevation. Superelevation is nothing but level difference between the 2 points A and B. Level difference between the 2 points A and B will be same only or not? Superelevation value on both tracks is same. Value is same. Numerical value is same, but the behavior is different, right? How it is different? Main track positive superelevation, branch track negative superelevation. So first option is wrong. Maximum speeds on both the tracks are interconnected. Yes, correct, right? Maximum speeds on both tracks are interrelated. Means can we allow any maximum speed on any track as you wish individually, or maximum speed on branch track is related to main track, maximum speed on main track is based on the maximum speed on branch track, both are interrelated definitely or not? Yes. So which options are correct now? B, C and D. All the three options are correct, right? Is that clear? Govind, Naren. Yeah. D option here actually what you are doing. If you just remember that first E theoretical of main, right? If maximum speed on main track is known, we'll be calculating the maximum speed on branch track or not. E theoretical count of main track equal to what? G into maximum speed on main track is square by 127 or main. After that what you are doing? E theoretical equal to E actual plus ED. Whenever it is for main track, you add positive superelevation here. ED we know, E theoretical we know. We'll be getting E actual of main. And what we have? We have that E actual of main equal to E actual of branch only numerical point of view. So whatever the centimeters or millimeters you are getting there, substitute the same value here. But what you are doing? E theoretical equal to E actual plus ED. Whenever it is for branch track, minus the superelevation for branch track. From this what you are getting? E theoretical for branch track we will be getting. After getting this E theoretical for branch track, first step, second step, third step. After getting this E theoretical for branch track, what you are doing? E theoretical for branch equal to G into V maximum of branches square by 127 or branch. From this we are getting V maximum of branch. Both are interrelated. Maximum speed on main track and maximum speed on branch track are interrelated, right? Individually they cannot be selected. They must be related to each other, right? They must be related to each other. If you know maximum speed on branch track, exactly the reverse manner you proceed and get the maximum speed on main track. If you know maximum speed on main track, get maximum speed on branch track exactly in this, right? Like that. They are interrelated or not? So option D is also correct. So options are correct now. Option B, C and D are correct. So again, this is our faculty team. This is my contact number. You can contact me at this whenever you are having any doubts. RP sir, KP sir and IR sir, we are the faculty team, right? RP civil is my plus referral code you can use. For subscription. These are all the subjects I will be taking in Unacademy Plus platform. These are all the advantages you will be getting when you are using my code RP civil. Okay. These are the classes you can see. Right? So whenever you are thinking to join these online courses, the best option is what? Unacademy, right? You can compare other online platforms with Unacademy, then only you can understand how Unacademy is better than others, right? We'll see. Marathon class actually they have to ask us to take marathon sessions. This Unacademy team is supposed to ask us marathon sessions so that we can select some topic and do it. Okay? So whenever they ask us, we'll be doing it. Don't worry. Right? Whenever they will ask, we'll be doing it. Don't worry. Okay? Thank you. Is that clear everything? All these questions are clear na? Shall I close the session now? Right? Okay. Thank you. I'll be closing the session.